The voltage drop equation is voltage drop equals 2 times K times I times D divided by Cm, where voltage drop is the voltage drop in volts, K is the resistance of the conductor in ohms per 1000 feet, I is the current in amps, D is the length of the conductor in feet, and Cm is the circular mil area of the conductor. To solve for Cm, you can rearrange the equation as follows: Cm equals 2 times K times I times D divided by voltage drop. To determine the appropriate wire size for a given voltage drop, amperage, and distance, the following steps can be taken. Firstly, start by selecting a suitable value for K. For copper conductors at a temperature of 75 degrees Celsius, K equals 10.37 ohms per 1000 feet. Secondly, determine the allowable voltage drop. Thirdly, substitute the values of K, voltage drop, I, and D into the equation Cm equals 2 times K times I times D divided by voltage drop. Fourthly, solve for Cm. Fifthly, refer to a wire table, such as Table 8 in Chapter 9 of the National Electrical Code, to determine the appropriate wire size based on the calculated Cm value. In an example, a Cm value of 11,274 was calculated for a current of 300 amps and a distance of 100 feet. Referring to Table 8 of Chapter 9 of the National Electrical Code, it shows that 2/0 copper wire has a Cm value of 13,310. Therefore, 2/0 copper wire would be suitable for this application. It is important to note that the amperage and distance values in the voltage drop equation can be any combination that results in the desired voltage drop. In the case of a second example, using 100 amps and 300 feet would also result in a Cm value of 11,274, and therefore 2/0 copper wire would still be suitable. However, it is generally not advisable to use wire that is rated for a lower amperage than the actual current draw. This can lead to overheating and potential safety hazards. Therefore, it is always best to err on the side of caution and use wire that is rated for a higher amperage than the actual current draw.